Sorry, I forgot to record the meeting. So, introduction to comparative programming. So, what is comparative programming, first of all? So, to many people, comparative programming isn't just typing out code, right? It's a sport that takes years to master. In fact, it's a hobby. Participating in competitions has many benefits, like getting a job, improving logical analysis skills, and expanding your creativity. We call it a mind sport. It's an activity where we are able to participate in events, solve specific problems or puzzles. And we have online judges, which are hosted on virtual machines that are able to help us solve a great number of problems under a time constraint. So the goal is to write a source code that is solved using a mathematical or logical problem. And such competitions have been around since the 70s. And the interest in events has grown significantly over the years. And now we have, in fact, international contests and a worldwide community of more than 50,000 people. And the benefits of like participating in such contests are that a lot of large companies such as Facebook, Google, Apple, they sometimes sponsor these events or they attend these events. So if you like participate, then there's a very high chance you might get noticed by the representatives. And that is one reason to participate. But what might be the other reasons to participate? Like, why would I want to spend hours and hours solving and practicing problems that are time consuming, require great and detailed understanding of concepts when I could be just preparing for job interviews? But the thing is that with competitive programming becoming so huge over the United States, not only the United States, but other countries as well, um, being an expert in this can make you a desirable candidate for different companies. Like tech companies, they track these competitions to find potential employees. And these large programming events, such as the ACM ICPC contest, where you have like over 500 different schools, more than that, in fact, about 3,000 schools taking part in it, with each school having 3 members who represent their teams. And schools that end up in the top 100 or even the top 500 are basically become desirable candidates for these big companies because they sponsor these events and they are extremely prestigious events. So it's extremely difficult to succeed in them. And if you do, then it's an indicator of your technical talent and abilities. So also when you try to practice for interview prep, the environment is very similar. You're solving 5 different problems in competitive programming contests. And similarly in interview prep, you'll probably solve 3 or 4 problems in a time span of maybe 1 hour to 1.5 hours. And with competitive programming, you're able to have a grasp of advanced concepts such as trees, advanced graph structures, minimum spanning tree algorithms like Prim's algorithm or Kruskal's algorithm that you usually wouldn't need to use in interview prep. And if you have an understanding of these concepts, you become you show an indication of exactly how you show an indication of performing in high pressure environments and engaging in problem solving. So also competitive programming requires teamwork. As I mentioned, a lot of students go and take part in these contests and there's 3 people in a single team. So one person would be like coding the solution, 2 other people would be working on the other solutions. So communication is extremely important in these high pressure situations. So with communicating as a competitive programmer in these large contests, in these global contests, when you work as a software engineer, you would also need these skills, right? And if you have these leadership skills, these management skills, then it translates over to your software engineering career or any career that you try to pursue in tech. So with competitive programming also, it basically trains you. It's like a mind sport. It's like chess. It trains you to participate in these programming competitions. You become more disciplined. You become faster in typing. You become faster in coming up with solutions, and your solutions are often very efficient. So you're able to solve problems with a tight deadline, and it teaches you how to focus on a task and efficiently execute in a short amount of time. So similarly, the whole goal about like competing is that the time restrictions factor is very important, because when you pass a code through an online judge, it has time constraints, like about 1 second. If your code runs more than a second, then it instantly gets rejected. So you have to produce code that runs extremely quick. Sometimes even languages play a huge part as well. Like Python is one of the slowest compiling languages, or Java too, but C++ and C is extremely fast. So because of that, you're able to produce code which has a lower time complexity, but at the same time, it's still able to pass the time constraints. So let me just emphasize more on the online judge. The online judge basically makes sure that the programs that you write, it conforms to a specific format of input. Like you're given an input and then you have an output. So if your program is able to match the input that is passed into your functions and it matches the output, then it will kind of run the test cases. But if you want to run like hundreds and thousands of different test cases, you want to make sure your program runs fast enough. So that doesn't happen, it doesn't mean your program will like fail instantly. It will give like a TLE error, means time limit exceeded. And so having a good knowledge of time complexities is extremely important. Like I'll give you a brief example. If let's say you want to get the if you want to get the to the power, like if you want to calculate the powers of some base x, and you want to calculate x to the power 4, like a simple solution would be to just multiply x by 4 times and just return z. But by doing that, you increase the computation time. So by breaking it down into 2 different steps, you could save a few hundred thousands of test cases. Like you could save the execution time on few hundred of thousand test cases. And such clever techniques, or such clever um, designs could help you produce new and better algorithms. Usually in competitive programming, the input format is given. I can show you after the meeting. I would be presenting for 5 minutes a website where competitive programmers usually solve problems, and I would be going over how a problem really looks like, and what it asks, what input styles are required, and then how are you supposed to produce an answer. So in general, you would have in the first line, you would have the number of test cases. And then below that, you would have like your test cases with maybe maybe 2 or 3 variables. Like here you have 2 variables. So you would have like 2 or 3 variables like that. And I would go over some tips of how you would be solving problems in the contest. So initially, when you start problem solving, right? What starts happening is that people who have not practiced a lot or don't have much experience in these programming contests, they start with brute force solutions. They will basically encounter problems, and they will produce simple algorithms that don't require optimization. Rather, they will just apply existing algorithms that are present in libraries, and they'll get a brute force solution working. But for for questions which have high ratings, what ends up happening is brute force is not the most efficient solution. So most of the times we'll get a time limit exceeded error, or your test cases won't even pass. So once your rating improves and you start practicing more and more, you start coming up with greedy algorithms where you make an optimal choice at each stage of the algorithm in hope of finding a global optimum. This is more efficient than brute force solutions, as long as you have a greedy solution for the problem. And then we have dynamic programming. So dynamic programming is a very important aspect in general of solving questions, because it's able to solve problems which have a lot of sub problems within them, save those problems, and use them in normal recursion. This reduces the time complexity and is helpful on problems which have recursive type solutions. And then you have graph algorithms. This is like a very advanced technique. You'll be using that when you end up solving problems with very, very high ratings and extremely complicated problems. Their graph algorithms would be extremely useful. I already mentioned a few. And similarly, knowing data structures and other algorithms is important, and especially practicing. What practicing would help you do is it would help you recognize different patterns in problems which are similar. So let's say if I'm solving a string problem or an array problem, and I solve maybe 5 or 6 problems similar to that, and then I try and go and solve a problem that I've never seen before, I can use what I've learned from those initial prompts that I solved on arrays to come up with an implementation and a solution basically for a problem I've never seen before. So practicing is extremely important, especially in comparative programming. It requires in-depth understanding of your data structures, your algorithms, especially the ones that are important, the common ones, especially. And it would also require you to have some sort of an idea of how to build constructive algorithms. A lot of the solutions you will see are not straight up combinatorics or discrete math. Like they're not straight up solutions where you would have to sort or use hash maps. Like you would have to come with a constructive solution to those problems. So having that sort of ability to come up with a constructive solution when with the existing tools is something that is extremely important for becoming an expert competitive programmer. Now, I already mentioned the ACM ICPC contests. These are prestigious competitions that anyone can take part in. I think for the ACM ICPC, you have to be a university student, but for the others like Google Code Jam or Kickstart or Top Coder contests or Facebook Hacker Cup or Code Forces, you don't have to be a student. You can just register on the website and they'll have specific, like Code Forces has competitions every week on Friday. So you can just register for them and they'll give you 5 problems ranging from like easy problems with low ratings to harder problems. But also depends on which division you're in. So I will come to that later. But that is a very good place to practice. That's where most competitive programmers practice, is on Code Forces, where they're able to solve a variety of different type of problems from a large database of problems, and they're extremely useful. Some of them even show up on these 3 contests. So I would really recommend that if you get some practice on Code Forces, you should register for these competitions and at least try them out, because it will give you a lot of exposure. And I'll come to the last thing, which is the rating system. So in Code Forces, for example, you have these different types of ratings. People who are interested in like gaming or like this is sort of a motivation factor for people. Like when they start solving problems, they want to see their ratings go up. The more they go up in ratings, the harder problems they're able to solve, and the higher contests they're able to take part in. Like, so specific contests are only built for people with specific ratings or above. Like if I'm, let's say, a grandmaster, I can take part in all contests. But if I'm like a newbie or a pupil, I can only take part in I'll only be restricted to take part in maybe 1 or 2 contests, because there's a restriction on the ratings of the people who can take part. So that's sort of a motivating factor for people to essentially like solve problems and compete. And at the end of the day, I would like, my final thoughts are about the goals and outcomes I have for the semester. So what I envision is I want to create an environment of people who are able to at least have or show in like people. I want to generate interest and build an interactive environment for everyone who's new to this field to solve problems, at least on a weekly basis, and eventually develop an interest for this field, so that people who already are solving problems and enjoying it can go and tell their friends, and then I want to grow this community here. So I also want to explain to people that that certain aspects, like when I started doing competitive programming, I just used to write up implementations or produce solutions, and it never used to run the test cases because I had no idea that an online judge required me to have certain like a template, like an online template where where you have to write your solution in a specific way so it can read your output and pass all the test cases. So that's something that you don't tend to notice when you start out initially. Then I want to explain the different problem types that people can expect. Like on interview websites like LeetCode, HackerRank, they have a set number of problems, a set type of problems that they can expect. But on Code Forces or any comparative programming website, it's a bit more complex. So having a good understanding of that is something that requires some amount of reading and going through articles and posts. So I want to make sure that everyone who's doing it on a regular basis is clear with that, and also they are able to comprehend all the topics and concepts that might be useful when they start out with these problems. And again, I said regular participation is extremely helpful. It's extremely useful. If you if you at least participate in one contest on a weekly basis, like on Friday, if you're just giving contests every Friday, initially you won't be able to solve a single problem, but after taking part in maybe 5 or 10 contests, you'll start seeing results. You'll be able to solve the first 2 3 problems out of the 5, and then once that happens, you start feeling motivated. You start feeling that you are able to comprehend, and you're able to uh, basically solve problems you've never seen, and problems which require a lot of complexity. So practicing is extremely important. And I think also something that might help out initially when you start out is that you should, like, working in groups or developing a small community might be extremely helpful, because when you work with multiple people on a problem, you tend to get the solution quicker. You see the thought process and the mindset of a lot of different people and how they approach a problem, and that can help you grasp and see different aspects of a problem that you might not be able to see. You might be able to hear it from them, and then it gives you a better understanding of how to solve problems, and it will benefit you in the future. So now I'm going to switch to the website to give you a slight demonstration of how, like, how to, like, pick problems and the different resources that are available on the internet. I will end up sharing these files at the end of this session, and if you have any questions, just email me. So I'll just stop sharing my screen and reshare it again. So this is the Codeforces website that I was talking about. Usually, as a beginner, what we do is that you would essentially just go on to problem sets, and you would select a problem with a specific rating. So for example, if you're a beginner, I would suggest to solve 800 level problems. You can set the ratings here, you can apply it. So 800 problems are the ones that require, like, are the most basic problems. They're the easiest problems on the website. And as a beginner, you should solve problems between an 800 rating and 1,000 rating problems, because they're usually the first problems that show up in contests. So when you go to a problem, you will usually see the type of the problem that exists. It'll show you the different, like, in contest it won't show you what techniques you need to use, but when you solve problems that already have been seen in contests, like, this is a collection of all the problems since probably 15 years that they built this database. And all of these problems, they keep updating this database every time a contest happens. So whatever problems um, were seen in the contest, they just add it to this database. So let's say if I want to solve this one, it shows the time limit that that is required as each test executes, the memory limit. So these are constraints that you need to um, take care about. You have the standard input and the output. So you would read the input from the standard input stream. If you're using Java, then you would read it from the input stream. If you're using C++, then you would read from the IO. This is the output stream where you have to print your output onto. And then you basically read the problem. You kind of develop an understanding of it. You try to think about, okay, if I'm sort of reading this problem, which different techniques am I able to utilize in a problem like this? Which approaches can I go with? So after, like, seeing, for example, this is like a staircase problem, so you could do something like DP or something like that. So then you have your input. they describe the input in more detail here. They say that what your test cases, how many test cases you have. In this case, there are 100 test cases, and what should be the size of each test case, like, which is given here, and then what your output should look like. And what you can also do is most of the times, if you want to solve problems, like when I solve problems, what I just do is, I mean, I would have to register and enter into my account. Then I can just start solving the problem here itself on the website. But most people, what they do is they build like virtual environments like Sublime Text or VS Code, where they create their sample template, and then they use those templates, and then they start solving the problems. I was initially planning to show the templates in the next session, but I think since we have more time right now, I could share it. I did make use of existing templates that I found from various people who are expert in this field. They build these templates and they post it on their repositories. So you can just go ahead and you can just type C++ or Java templates for competitive programming. It will show hundreds of certain different searches, and you can pick one, whichever one you want to use. Because when you start initially solving, these templates are not that important, but once you start solving, let's say 1500 plus problems, then templates are useful, because you don't want to keep defining, let's say, an array or a vector. Like, you don't want to keep defining those different containers that you might use. If it's already predefined for you, your solution will only be a few lines. The whole idea is to have a solution as short as possible. You don't want to have a solution that exceeds over 50 lines, because then none of your tests will run in the given time. So I can show an example of a problem that I solved. Let me sign in and then share my screen again. So this is my submission history for, let's see. So this was a very simple problem, finding the min sum. So initially, when you start solving problems, you would have a main function. I did it in C++ because that's the most common programming language. It's extremely fast, and because of the STL library that has so many functions, you would want to use that. Because Java and Python don't have extensive libraries that you can use for CP, so you would want to use C++. That's what I would suggest. So initially, you would want to have the definitions and the declarations on top. This was a very simple problem, so I didn't need many. But as you can see, I print my output to the console here. I read my input. So T is the test cases that I'm reading. using the C in operator and the C out operator, I'm able to print it to the output. And then this is how it looks like. And then this also shows the time your implementation took, the amount of memory it needed, and then whether it passed or not. And this is for each test. So in order to debug code, it would be very useful to have a virtual environment where you could just import these test cases and then you could debug your code over there. Similarly, for a more extensive problem, such as here, you can also print, you can also do it in this way, but it's pretty much the same solution. I'm gonna find it all. Yeah. So pretty much on this account, I've only solved a few problems, but in general, there are a lot of templates out there where you would have it, which are able to import all those libraries and all those, define all those collections, those vectors, those arrays, and anything that you might need to solve your problems. It would already be predefined, and you can just write your answer in the main function. So last but not the least, I will share a document with a couple of resources out there that you might find useful, such as books or any websites where you can learn how to learn the different algorithms that you might not already know. And that might be useful when you start solving these problems. So what I like doing is I like starting with the CSES problem set. This is a basic problem set that a lot of beginners start with. It gives you problems on the basis of ratings on the different types of problems that you might want to solve, like intro problems here, the most basic ones that are commonly asked in competitions or that you might commonly notice over a lot of different websites. And then you have sorting problems, you have dynamic programming, graph algorithms, range queries, tree algorithms, then math problems that include discrete math, combinatorics, then string problems, geometry, etc. So if you start solving on this, if you like having if you want to start comparative programming as soon as possible, or anytime anytime you want to, you can always refer to this website. This website is extremely useful, and I'd highly recommend it because you'll be able to keep track of all your submissions. You'll be able to keep track of which areas if let's say you're lacking in sorting or in strings or any graph problems, you can always go and solve them. And these problems will essentially build like your base. And when you start solving problems in contests, you have some experience with each of these topics. So when you start solving these problems in contests, you won't be lost. So I think this is extremely useful. And I think I have shared most of what I wanted to show. I will talk more about the ACM ICPC contest in my next session, where actually I can just introduce it right now. Maybe the website might be helpful. So you can take a look at it before the next meeting, and it might give you sort of a idea of what really the end goal is for competitive programming, or what a lot of university students end up doing. So there are yearly contests happening where almost about 400 or 500, maybe 1,000 different schools, like 3,000 different universities in this, according to the statistic, take part in these contests on site. And they first pass through these regional rounds where they compete against schools in the same state. For example, if I'm in Wisconsin, then a school from Wisconsin would be competing against other schools in Wisconsin, and then the top teams from out of that state would go on to take part in these on-site competitions. and they become part of that contingent's representative. So for North America, there would be about 25, 30 teams, which would come out of all the regionals, and then would represent their country on a global stage. So exactly, that's what I was talking about, regionals right here. So you can basically click on that to know more about what regionals are, what problems they have, for example, over the years. So I mean, there's a lot of other things too, like you can see their solutions. And then you can, if you're interested about the world finals, where there's about, I would say about 100 teams that take part, maybe 150 teams at best. Then they have their different problem sets as well. Usually regionals have easier problems, and world finals obviously will have much more complicated problems. But the fun part about going to world finals, from what I've heard, is the amount of exposure you get, because a lot of students who take part in these world finals have competed in international Olympiads when they were in high school. So they had got a similar experience in the IOIs that they took part in. So for taking part in ICPCs, even if you haven't done any Olympiads before, it's a great experience. And you'd be able to meet with a lot of people from other countries, from other schools. It would be like, it would be an on-site competition of at least about 1,000 people would be present there, from sponsors to students to representatives, etc. So it's like a great experience overall, and the whole trip is paid for. And it happens in cities such as London, Istanbul, Moscow, sometimes in Asia as well. So it's a really fun event to go to. Even if you aren't a participant, you can still register to attend it, just to be an observer. And I guess it would be a great opportunity. And now um, I would open the floor for any questions that anyone might have before I end the session. And um, if you want to know where this club is heading, or what um, my vision might be for the future, then you can just feel free to ask if you have any concerns, or where do you see this heading. If not, then I can end the session, and it will be available on YouTube as a recording. And in the next session, hopefully we can select a time and availability to meet over the weeks to practice. And then once we have these workshops, I can present specific problems that we found interesting in our weekly sessions, and we can work on it together. So okay, let me check the chat. All right, then I guess there are no questions from anyone, so I will end the meeting, and hopefully see you next month in the workshop. If you're interested in working on this together, solve problems together. In the meantime, just send me your availability, or when or your schedule, so we can like meet twice or thrice a week to work on maybe 3 problems a week, and then we can come up with an interesting problem to solve in the workshop, or work on, or talk about a specific topic in the workshop. So see you next month, I guess, or whenever, whoever's interested. And I will like produce a Google form, and I will post it on the Discord and our other socials with an availability timesheet. And if you're interested, you can fill up those forms, let me know your availability, and then we can schedule meetings, and we can meet in Discord or any private rooms, or in person as well if you prefer that. So all right, then see you next month then. If Hari or Shubham have anything to say, you can go ahead. So before I end the meeting.
No, Vedant. That'll be pretty much it.
All right. Sounds good.
Thank you, guys. Thank you, Vedant.
Yep, thank you.
Mhm.